Is it possible to boil water without any heat? In this video, I'll try to prove that I can actually make water boil without the need of a heat source. Before we start to investigate, we need to understand what it is to boil something. If you search up on Google the meaning of the word boil, I get this: with reference to a liquid, reach or to cause to reach the temperature at which it bubbles and turns to vapor. So it is to reach a certain temperature where a liquid becomes a gas and it also bubbles. So with the definition, let's boil some water. Now we wait for the water to start to warm up and reach that temperature at which it starts to bubble. We can now confirm that this is to boil water, so we need to see this happen but without the high heat from this fire, to be able to boil water without heat. To boil water, we need to reach a really high temperature where the liquid becomes a gas. This temperature is called the boiling point, and for water it is at 100 degrees Celsius. The boiling point is different for different types of substances. For example, butane has a boiling point of -1 degrees Celsius, and methanol has a boiling point of 64.7 degrees Celsius. We want to be able to boil water without reaching the temperature that is the boiling point. So instead of increasing the temperature to the boiling point of water at 100 degrees Celsius, is it possible to bring the boiling point down to around room temperature? This can actually be possible by changing the pressure in the atmosphere around the water. So now we have to understand how pressure works so we can bring the boiling point down to around the temperature of my room. Now we're going to use a simulation that I made to understand what pressure really is. Pressure isn't the amount of stuff in a certain space, that's density. As you can see in the simulation, the particles hit the edge and this caused the force pushing on it. The amount of force in a certain area is what pressure is. Pressure can be affected by heat and how compressed the gas is. Because if you didn't know that if you zoom into a hot object, it's just its particles are moving really fast, therefore hit the edge more often, so there is more force. If the volume stays the same, the pressure of a gas increases with the temperature. They are directly proportional. This means that if you put pressure against temperature on a graph, there would be a straight line. Pressure also affects heat. An increase in pressure can cause a spike in temperature. This is used in some piston engines with long enough pistons and don't need spark plugs. A long time ago, the King of Random made a video on a piston that could make fire, link in the description. Also, the lower the pressure, the colder it gets. That's why the higher you climb a tall mountain, it gets colder. So you would think that the higher the pressure, we would be able to boil water in my room with low temperature. But actually, if I increase the pressure, the particles would come closer together, like me applying pressure to this snowball. Particles come closer together, becoming more solid. So instead, we would have to decrease the pressure around the water, and it would want to fill up the area where there are less particles, so therefore boil. It is literally impossible for an object to have no heat whatsoever. That's why all objects have at least a bit of heat energy, even if you don't feel it. Cold objects have heat, but they seem cold to us because we are warmer than them. Room temperature actually has a lot of heat, but it doesn't have enough heat to boil water. According to Wikipedia, this is called a phase diagram, and it shows what state of matter water is at a certain pressure and temperature. Just as we predicted, the lower the pressure, it is closer to water vapor. It only becomes solid under 0 degrees Celsius, and it only stays water at high pressures. Room temperature is around here, and if we lower the pressure enough, it can be in the gas state. And in pressures that we normally live in, it is in the liquid state, as we would expect. So now I'm about to show you how to boil water without fire, heater, kettle, or any heat at all. First, let's try to boil water that has already been heated to 50 degrees Celsius more or less. Because if we boil water without heat, it loses all of its energy fast, as heat isn't being added. So I'm going to use a syringe and plug the end with my thumb. Now I'm going to pull the syringe so the volume that is added on top of the water is now close to a vacuum, so at really low pressure. As you can see, it is boiling but then starts to slow down. That's because the heat is taken away by the water vapor. Now we're going to boil with water that just came out of the tap, and it should boil but slow down faster as there is less energy. As you can see, that is exactly what happens. You can try this at home just with a syringe and some water. You can surprise everyone that you have magic to be able to boil water without any heat. That's the end of the video. Please subscribe and thanks for watching.